Hello, let's solve pips. We've got 2 by E and 1 by Rodolfo today. We'll start with the easy puzzle as usual. Let's place some dominoes. Apologies, this is coming so late in the day. I just haven't had any time. I had to take a flight and still not home. All right, we have 1 connecting to 1. So this could be 1, 1 or 1, 0. If it's 1, 0, it can't be actually, because then the rest of it would need to be 0, 1, which we've just used. So it has to be 1, 1 with a double 0. And then here's another 1. Here, oh, 2 goes here. Could have done that right at the beginning. 6 goes here. So the only way to finish this is 1, 0 here. Great. Let's try the medium. Okay, we have 5s pointing up and down at the top and bottom, and 6s pointing left and right. So we only have 2 6s. Right, so they're going to be these 2, but they may not be these particular. In fact, they definitely won't be these placements, because we would need a double 3, which we don't have. So actually I need to immediately flip these. I should have looked at that before I put them in. So the double 1 goes there. We need a 3 here connecting to a 6. We only have 1 3, so this is 5 5, which we do have. So our other 5 points up here. We finished the double 4 region. Oh, wait, did I do this wrong? It looks like these can go either way, because less than 2 could be 0 or 1. That makes me think I made a mistake. No, I didn't. So those just could have been flipped. Okay, fine. Let's do the hard. Year. Why does it say year? Was there something yesterday that this is continuing? I'm not sure. Look at all these 1s. We have a 1 here, a 1 here, 2 1s there, a 1 over here. Oh, you can't see the cursor. Sorry, that's annoying. I don't know why my computer why this particular computer doesn't show the 1s. All right, well, we've got this 1 region down at the bottom, which could have a double 0 or a 1 0. Actually, how many 1s do we know we need? We need 1 in the 3-cell 1 region, 2, 3 in the A in total, 2 more in the Y, that's 5, 1 more in the E, that's 6. How many do we have? 1, 2, 3, 4, 5, 6. Okay, so we cannot waste any 1s. We can't waste any 1s. What does that mean? Could we do this? I don't see why not. Could we do this? If we do this, we need a 0 connecting to an 11, which is fine because we could do 0, 6, or 0, 5 actually. So I don't see a problem with that. We have 2 cases of greater than 11. Could we do this greater than 11 with a double 6 here? We would then need this to be double 1. I don't see why that's a big problem. In fact, you know what? We might have to do that because we can't waste any 1s. And I don't think there's anywhere else we can put a double 1. That's not true. That's not true. We could put the double 1 here. Oh, that's annoying. We could put the double 1 here and a double 0 here. Is there anywhere we can put the double 0? Maybe that is what caused, maybe that's what, oh no, we could put it over here. So this would have to be a 1, 6. I guess I'll just see if this works. This would also have to be a 6, and this would have to be 6, 5 in a single domino. Oh, and that doesn't work. That's why this doesn't work. We don't have a 6, 5 in a single domino, so that's not possible. Okay, fine, good. So actually that means the double 1 does need to be here. And the double 6 needs to be here. So this is either, I mean, we don't know if that goes there because it could be a 1, 0. So this is a 0 or a 1 connecting to a 6 or a 5. And we have 1, 6 and 1, 5 and 0, 6 and 0, 5. Yeah, so any of those works in theory. This greater than 6 needs more. Okay, so what about how many 6s do we still need? We need 1 in the 11, 2 more in the small r. That's 3. Oh, those are actually, oh, those are the exact ones we need. We only have 3, and it's exactly those. Okay, fine, that's useful, I guess. Right, so where must they go? The 6, 1 then cannot be wasted. So I think actually it must go here, right? Wait, did I say we needed 3? Where are those? Where did I get that? Oh, right, because this is greater than 11, so it's 12. Yeah, that is it. That's right, and we can't waste a 1, and we can't put a 1 over and we can't waste a 1 over there, so this does go here. This is the double 0. We need another 6 here, so this is either 6, 0 or 6, 2. And it points up and goes into a void, so we don't really know which. No, that's a 5. Sorry, that's a 5. The 2 6s go over here. So this goes here, and the 6, 2 goes in the grid 1. Sorry, I'm not operating at full steam, clearly. So this double could be a double 5 or a double 2. I don't think I know which yet. And our 1s actually are forced, right? They go down here. Oh, wait a second. This looks bad. Because now we need another 6 and we don't have one, so I've done something wrong. I've made a mistake here. Wait, how does this work? Oh, sorry. This is sorry. No, wait, no, that doesn't help. I was going to say this goes here and this goes here. Oh, no, that's right. That's correct. This is correct. Now we put a 5 here. Yeah, sorry. No, that's wrong. Because we still need another 6. Wait, how did I make this mistake? What did I do wrong here? Sorry, I've made a dumb mistake and I don't know what it is. I feel as though I just don't have enough 6s and I can't figure out what I've done that caused that. I must have somehow made a mistake. I must have made a 1-related mistake. Oh, we still have another 1. Oh, sorry. I miscounted 1s. I thought we couldn't waste any 1s, but... Oh, because this goes over here. Sorry, I didn't miscount the 1s. I just didn't realize I hadn't finished them yet. That goes here, and this is a... No, this still doesn't work. So this has to switch back. Sorry, I was coincidentally correct previously, but wrong in a different way. That goes here. Now this is a 2. Connecting to a 2. Okay, sorry. That was all bad, but I think I've finally fixed it. So this is a 5. This is a 0. Sorry, you can't see where I'm pointing. I don't know if this is the case. I'm just doing this so you can see where I'm pointing. This is a 0 something. Oh, and our equivalence only has 5s left, so that does go here. Now we have 2 5 possibilities that go in there, and 4 0 possibilities that go here. And we also have to add to 11. So what are 3 things we have that add to 11? 3, 4, no, wait. 3, 3, 5 it could be. I bet that's it. That might be the only... No, we could do 5, 4, 2, actually, as well. I don't know. I'm just going to try something because I don't have a lot of time. 3, 5, 3? No, we can't do that. We need something greater than 1 there. That's interesting. How does that work? Wait, I don't know how this works. I think I may have made an error. Oh, wait, no. And then 5, 3. Okay, that works. No, this doesn't work. This needs to go here. Or something needs to go there. This needs to go here, maybe. Four, 9, 2. Sorry, 4, 5, 2. Yeah, this works. This works. Sorry, that was a little chaotic. Whew, what we got there. Okay, sorry, that was a bit of a mess of a solve. Not very eloquently explained, nor elegantly solved. But we got there in the end. All right, those are the pips. Back tomorrow. Bye for now.